Retro.
Yeah.
Electro. Tech.
Oh yeah.
Hey, turn the lights back on. Wow. Retro Electro Tech. When real audio ruled the world.
Well, hello there everyone, this is Retro Ernest of Retro Electro Tech. And here on the bench today is a Marantz Model 27. This is a 30 watt per channel into 8 ohm receiver from around 1970. So otherwise everything looks really good, really clean, nice wood case, the face looks really nice. I will be spinning this around in a little bit, taking a look at the back side of things. It looks like it was very well cared for. Hopefully when I get into the inside of the unit and slide this thing out of the case, the internals will look good as well. Hopefully everything is mostly original, if not all original, and unmolested. If there was servicing performed over this unit's life, hopefully it was done to a high standard. And I just want to mention that this unit came in working order according to the customer. Now I haven't powered it up yet, checked things out, but obviously I'm going to get into that in a moment. The customer states that there is some noise in the controls. I don't know what controls are affected. Again, I'm going to get into that in a bit. So yes, I'm going to spin it around, we'll take a look at the back, then I'm going to jump on in and we'll take a look on the inside to make sure everything looks good via the initial cursory inspection. If everything looks okay, and there's no red flags, nothing scary going on inside, then of course I'm going to perform a safe power up. Even though the customer stated that this is a working unit, always do a safe power up. Always a good idea. You don't want something catastrophic to happen on your bench because you just assume that everything was good. You know, verify that. So anyways, and if everything looks good there, then I'm going to get a signal into it and start function testing things, the controls and all that, find out what controls are noisy, intermittent, whatever the case, and go from there. So anyways, let me move forward. Okay, let's spin this bad boy around. We'll keep this very brief. Just want to take a quick gander back there. Everything looks, well, like it should. Everything looks pretty clean back here. We have a couple of receptacles. We have a little circuit breaker, our speaker terminals. Let me pan down here. We get a little more light on the subject there. So our antenna hookup and some input jacks. So yeah, that's really about it. And it does have a service sticker there, by the way. So there's that. Otherwise, yeah, let me get it out of the case and we'll take a look inside. Okay, so here we are looking into the top side. Everything's looking pretty good so far. I don't see anything alarming in here. I'm kind of passing through with my magnifier and I don't see any electrolytic caps that are bulging or otherwise look like they've vented open or are about to vent open. All the other components look pretty good. Nothing looks like it's become really hot, discolored, charred. Anything that looks cracked or blown open, anything like that, all the wiring looks good, so good. So far so good. So we've got our front end, AM FM front end, our tuning condenser, some coils, tuner board here, some AM FM, you know, our IF multiplex stuff here, some IF strips and all that jazz. We have our phono stage here, we have our preamp board here, we have power supply board, our illustrious transformer, our main amp board here with its old TO39 transistors, our drivers with their plastic insulative sleeves. They're sitting on like a ceramic material, kind of a base. You know, they're sitting on some ceramic bases. I think it's ceramic or something like that. But anyways, yeah. And yeah, so far they're still going. So I'm sure at some point they'll probably start getting a bit noisy, but according to the customer, everything is working okay other than the noisy controls, at least as far as I know at this point. But I'm going to be getting into that next. Going to get this safely powered up and go from there. Oh, I didn't point out the main filters there. So let me spin this around and show you guys the back side. So yeah, the boards are all looking good from what I can see. I'm sure that if I spent some time with the magnifier, I could probably find some solder joints that could use some touching up for sure. That's usually pretty common. But just from what I can see, with this initial pass here, everything actually looks pretty good. And then we have some control access here. You know, we have a selector switch here. We have some pots. Yeah, up on this board as well, and we have some push button switches tucked up in here, as well as tucked up in here. So I am going to end up pulling these out just so I have better access, so I could kind of hold them and kind of tilt them a little bit when I'm flooding them with solvent and working the shafts and all that stuff, exercising them. I like to be able to, if I can, you know, kind of flood them and, you know, tip them for drainage and while I'm working them and all that kind of stuff, just to flush out any accumulation, any dust and crap, and maybe old lubricants and whatever gunk has built up in there over time. I like to be able to do that. So yeah, even though I could access the ports on these controls here, at least these ones here. So everything looks good enough to where I feel okay about getting this powered up on the current limiter. I'll watch it for a little bit and then get a signal into it. Check the right and left channel as I'm working the controls. See what's noisy, intermittent, whatever the case, and then go from there. Oh, and I almost forgot to mention before I move on, something kind of important is that there was some electrolytic recapping done on these two boards, the power supply board, this preamp board here. There's some newer electrolytics, some Nichicons, with date ranges between 2018 and 2021. That's what it looks like based on the date codes. So I just wanted to bring that up now. That seems to be these two boards here seem to be the only places where there was any electrolytic recapping done. Everything else appears to be original. Not only the electrolytics, but all the parts. They all seem to be original other than these two boards. So the work looks good. It doesn't look problematic. It looks like it was done right, up to par. It doesn't look substandard at all. So I just wanted to bring that up. So now let me move on. Okay, so I performed a safe power up and everything is looking good there. So nothing to report. I didn't want to roll any video footage on it because I often do, and I will again, but this time around I want to move on and just get to what I'm doing before I get a signal in this. So I wanted to check the DC offset, as I often do, or well, always do. I always do, but I just don't film it because it's pretty routine stuff, just checking the DC at the speaker terminals. And as you can see, if you notice on the meter here, on our left channel, we're up at 360, yeah, about 363 millivolts DC. We should be as close to zero as possible. And a little bit of offset is not going to hurt anything. You know, single digit millivolts, whatever. Sometimes too, you'll see double digits, as long as we're not getting up there too high. And, you know, we're bringing about, you know, distortion, and at the extreme end, we can see damage to the speakers, you know, heating up the voice coils and all that stuff. There's too much DC voltage sitting at the speaker terminals there. We can, yeah, burn out speakers, cause damage, all that stuff. So this is up there pretty good. And on the amplifier board, there's a couple of trimmers here, R509, R510, to adjust those down. So I'm going to go ahead and do that off camera because I need to get in here and focus on what I'm doing. The camera's kind of in the way and I don't want to move stuff around too much. So I'm going to be tweaking around, just get my screwdriver in there. I'm going to tweak that around. It's a very sensitive adjustment anyways. So I'm going to try to bring this as close to zero as possible, see where I can get it. So I'll be right back when I do that. Okay, so now you see it sitting around 14 or so millivolts. That's the lowest I could get it right now. The adjustment, the trimmer pot is so sensitive. And plus I think it's just, besides being old, it's dirty. What I'm going to end up doing is I'm going to hit it with some contact cleaner and just work the trimmer over and over and over again and see if that helps things out a little bit. But these single turn trimmer pots are very, very touchy, and on top of that, when they're dirty and just old, sometimes they're really hard to bring into adjustment. But I mean, 15 millivolts, even if I had to leave it at that, that's way better than almost creeping up to 400 millivolts. But I think I could get it a little bit better than that. I just need to clean up these trimmers a little bit. So anyways, I'm going to switch on over to the other channel and see what we have there. Let me just go ahead and do that real quick. And then, depending on where it is, I may have to shut the camera off again and sit around for a little while and tweak that and see what there is to see. Yeah, that one is, 320 something. I'll get my arm out of the way in just a second. Let me get the screwdriver into the slot there. Let me see what I can do there. Let me see if this one is just as bad. Because, man, I just couldn't. Okay, wait. Yeah, this one is a little bit better. Just a hair. Not by much. Man. Okay. Yeah, that one's a little bit better. So what I am going to do, though, is I'm going to go ahead and I'm going to spray these and tweak around with them a little bit more, and then I'll come back when I get those trimmers cleaned and get the DC levels on both channels closer to zero. See how close I can get it. So I'll be right back. Okay, so there's the right channel. That's about the best I could do, is keeping it down here in the single digit millivolts, which is fine. It's going to creep up and it goes down a little bit. It kind of bounces around, but that's the right channel. Let's move over to the left. Okay, and there's the left there. Jumping around 8 millivolts. It goes up a little bit, down a little bit. Again, jumps around a little bit, but we're down in the single digits. That's good. That's the best I can do under the circumstances. We have a lot of old parts here. There's parts on the amp board that are probably a bit out of tolerance and all that stuff. So I'm not going to get everything perfect, but that's way better than where it was for sure, in the hundreds of millivolts. So let me move on. Okay, so via the auxiliary inputs, I have a 1 kilohertz tone piped on in, and if you notice the oscilloscope display, we have our 2 channels. They are stacked on top of each other, and let me go ahead and zoom in a little bit. Okay, so I've already been through the controls to some extent. I haven't serviced them as far as flushing them out and relubricating them and all that, but I've gone through and just ran them dry, exercised them a little bit, rotated the pots back and forth, did some clickety click on the switches and all that, just to work out some of the kinks. So the controls that I found to be the worst are as follows. For example, the selector switch, and by the way, the ghosting, if you will, of the waveform that you see coming in and out and all that, that's being produced by the overhead shop light. Especially when I have equipment open, sometimes it will do that, and it'll produce a little noise like that. But anyways, I'll go ahead and shut the overhead light off, and you'll see it go away. Okay, so like I was saying, the controls that seem to be the worst are as follows. The mode selector, right now I have it switched over to auxiliary. I have a 1 kilohertz tone piped in. So you'll notice if I start to click over the selector switch, you'll see a little noise in there. You could probably see a little bit of noise, right? Yeah, I'm sure you can. Okay, It's not too bad. It was a little worse earlier when I first started, working the kinks out of the controls. But again, the customer knows what I'm talking about because he brought it in because noisy controls. So anyways, but I worked the kinks out of it. And one thing I'll say about that is you can do that, except when the controls are in really, really bad shape. Sometimes they don't even respond to just running them dry back and forth and trying to work out the kinks if they're really bad. But even if you work the kinks out and you exercise them dry, the problem is going to come back. So the only way to really deal with it, like I said, is a good, thorough, multi-flush cleaning. Really flood the controls while you're exercising them, rotating pot shafts over and over and over and over again, and working the switches, the switch contacts over and over again. Get good access into the controls, and flush them multiple times. Let them kind of dry out and drain out in between flushings. Try to get out as much crap as you can, and then follow up at the end of everything with adding the appropriate lubricant like Fader lube in just a small amount, a few drops or so, and exercise the controls again and all that. And then that'll buy you quite a bit of time before the controls will have to be serviced again. So anyways, moving on, and I'll just go through real quick, even the controls that were and are behaving well at this time. So the balance control here, that never gave me any problems. That's been good even from the get-go. The volume control down on the low end here, at first there was a little bit of noise. It's doing okay now, but I'm sure that if this thing sat for a while again and whatever, again, there would be noise once again. Like I said, you can work the kinks out a little bit if the controls aren't too bad, but the problem, the noise and all that crap will come back. But the volume control otherwise is doing good, okay, at this point. There's a little bit of kind of jittery behavior, a little bit of noise there. You might be able to see it in the bass control. Yeah, you see that? Yeah, of course you do. All right. But otherwise, other than that, it's not too horrible. The treble control, on the other hand, you see that noise in there, riding along the outline of the waveform. See that noise? I can see it pretty good on my end. I don't know how it's translating in the camera there. So the treble control seems to be a little bit worse than some. Now, as far as some of these switches, the tape monitor switch is pretty bad. You see that? Of course, I think you can see that pretty good. So when I push that in and out, that's pretty noisy. Okay, that control really needs to be worked. It needs to be flushed out real good and worked and all that stuff. All right. And other than that, the loudness. There's a little bit of noise in the loudness switch. You see that noise in there? All right. Low filter's pretty good. And everything else seems to be okay. So there we go. All right, so as the customer stated and as we saw on the scope, we have a working unit. Nice, clear, crisp and clean waveforms on both channels. No visible distortion. Everything was looking good, in other words, on the scope anyways. So other than that, what I'm doing now is just monitoring bias. I tweaked it a little bit. You'll see it kind of drifting around on the meters. The factory calls for 7 millivolts. And, again, with some temperature change as the amp runs and, as components, heat up and whatnot, and the temperature tracking diodes that monitor temperature on the heat sink, as all that stuff moves around a bit, yeah, there's going to be some fluctuation. You're going to see those measurements there climb, go down, go back up and down. So anyways, we're pretty much in the ballpark. I'll be tweaking it around and monitoring things a little bit. And let me just real quick zoom over here. You can see where I have the probes on both channels there. If you visualize just kind of down the middle here, okay, just right down the center there. We have one channel and the other channel. So I'm clipped onto both channels, as you saw on those two DMMs there. I'm monitoring both channels and just kind of tweaking things. Now I'm not going to point out in detail what's going on. Matter of fact, let me bring a little bit more light over here. But back in here, there's a couple of, well, there's a variable resistor or a trimmer pot right there, and then one down in here that you adjust. I'm clipped on to some resistors in the back. All this is in the service manual, so I'm not going to go into a lot of detail, but for those of you that are more familiar with this whole process and what this is all about, I'm setting the idle current, okay? So for those of you not too familiar with what's going on, electrically speaking, your amplifier has to be idling at a certain current, at a turn-on point called or referred to as a quiescent or quiescent idle point. So not unlike that of a car's engine, okay, if you have a car that has an idle too low, it'll you know, sputter, stall out. If it's too high, it's going to run hotter, you know, it's going to be revving up high. It's going to be less fuel efficient, you know, burning more fuel, all that kind of stuff. In other words, it's not operating at peak efficiency. So same thing with the amplifier. It needs to be idling just right at that turn-on point. So when it's passing signal, it does so in an efficient manner, and there isn't any type of lag or you know, the amp's not running too hot. So that's about it in a nutshell. I'm not going to get into a lot of detail, and not here, not right now. So otherwise, yeah, I'm just going to keep monitoring things, and you know, I'll go back down to the meters. You can see we're right about 7 millivolts. So things are holding pretty good. Also, too, another thing to consider is that, you know, the age of this unit. It's populated with parts that are mostly 50-something years old. There's been a little bit of work on a couple boards, some electrolytic caps replaced, but as far as this unit working at its peak in terms of sonic performance, reliability, some future proofing and all that, it will need restorative work. There's components that I'm sure are drifting out of tolerance to some degree anyways, and yeah, just a lot of old parts. But it's functioning. I'm sure that it sounds okay even as is, but could it be improved? Certainly. You know, it's an old unit. It's over half a century old, so there you go. So anyways, what I'm going to do now is, you know, just monitor the bias a little while longer, and then I'm going to power test things. We'll go back to the scope, and I'll see what this thing is putting out as far as watts per channel. And then I think I'll be able to just wrap this up, you know, just get into servicing the controls and doing a little bit more inspection, cleaning things up a bit, and it'll be good to go. If down the road the customer wants some restorative work performed, you know, we could schedule that in at a later time. But for now, I think we're good. Let me go ahead and get to some power testing real quick. Okay, so a little bit of a detour before I go into more testing and, you know, power testing, like I said. So I had to pull the amp channel out a little bit, or the amp section out a little bit, because I want to get to the bias trimmer pots in these areas back in here. Hopefully I can reach in there and get these desoldered. I'm pretty sure I can. I'm having a bit of a problem on one channel with the trimmer pot, and there's a bit of drift. It's very, very hard to set. And yeah, I tried cleaning the trimmers initially when I first got into setting the bias on this. You know, I sprayed them down, exercised them quite a bit. But there's one trimmer that's just very, very problematic, and it's really hard to set. And then when I do get it in the ballpark, it just kind of drifts back out. And that could be on account of, you know, just drifty components in the bias circuit, you know, that regulate the bias circuitry and all that stuff. There could be some of that going on because of the age of components and all that, as I mentioned. But it seems to me like it's more attributed to to the trimmer itself, just being very, very fickle. And again, these are really old parts in here. So I have a couple of, and let me turn down the exposure a little bit so it's not so blown out. But I have a couple of trimmer pots here, 1K Bourne's trimmer pots. They're multi-turn. I think they're like about 15 turn pots. So that's going to help things out quite a bit. So anyways, I'm gonna get into it and get this desoldered and whatnot, and start the process over again, set the bias, and see if I can dial things in a little bit better, which I'm sure I will be able to, despite the fact that, again, like I said, some of these components are probably just a bit drifty. Alright, so the new bias pots, the blue ones right here and right here, are obviously installed, so I'm going to get the heatsink tightened back up and then move on to power testing. So let me go ahead and bring this waveform up into clipping and see what we've got. So here we go. Let me flatten out right about there, back it off just a bit. Okay, so it rounds off a little. There we go, right about there. And yeah, we're doing 36 watts per channel into my 8 ohm load. Pretty good. So it's exceeding its specs just a little bit in that department. Yeah, all things considered, this is doing pretty good. So I'm just going to leave it at that for now. I am going to do some more testing. I'm going to check the the other inputs and get an antenna on this thing, make sure it's pulling in stations. We have multiplex, our stereo lights coming in. I'm going to do all that, and of course when the customer gets here I will audio test it, but otherwise I've gone far enough on this as far as the video goes. We get the gist of things. It's working, it's doing what it should. But otherwise, thanks for following along. As I always say, peace, love, music, and the vintage audio that brings it to your ears. Till next time, y'all take care.
This has been a Spinning Head production.
Hehehehe